Hello friends, welcome back to my channel Creative. I am Mr. G. Pujari, working as an assistant professor in Sharan Institute of Technology, College of Engineering. Welcome back once again. This is my creative channel. On this channel, I am uploading the video content related with engineering, technology and general knowledge purpose. So friends, I appeal you subscribe my channel, like my videos. So friends, in our previous lecture we have started already this topic, production drawing and reading blueprints. So just I am going to give you some overview whatever we have learned in our previous lecture. So friends, in our previous lecture we have discussed about the production drawing. So what is the importance of production drawing as per student for your curriculum point of view, and when you are going to enter in industry, what is the importance of production drawing as an engineer. Then friends, also we have discussed about the drawing sets. So what is the elements of production drawing that we have seen, like the process sheet, then limit fits tolerances, then what kind of surface finish, then inspection testing methods, specification of standard components, that what kind of things we require to include in a standard drawing. And also we have discussed with some example of drawing. Then we have seen about the limit fit tolerance, what is mean by limit fit tolerance. Then we have discussed some examples. Then we have seen with examples like clearance fits, transition fit, interference fit. Then also we have seen hole basis and shaft basis system. Then with respect to this example we have discussed earlier. So what is mean by unilateral, bilateral tolerances, then what is the surface roughness, why surface roughness important, and how it is measured, then what is the evaluation length, and what is the unit for this surface roughness array, how it is calculated, then whatever the instrument using for measurement of surface roughness like telesurf, that we have discussed. Then how the plotting of graph is done, that also we have discussed. Then some examples of material, that also we have seen. Then the process like turning, how it can be achieved with respect to whatever the array value. Then we have seen how the machines, when we are performing some operation like vertical milling, horizontal milling, turning, grinding, flat, lapping, rimming. So what is having, how the part will looks, okay, how whatever the array value and whatever the surface finish of that part, how it looks, that also we have discussed. Then what is the symbols, when you want to put the symbols on a drawing, how to denote, what kind of operation you require. So that also we have seen how the writing, what is the method of writing or whatever on a drawing. So friends, that also we have discussed about the roughness array value. Then we have also discussed about the process capability of every process like turning, milling, then grinding, polishing, what kind of capacity, because every process is having its own process capability. So what kind of array that can be able to achieve. So friend, last lecture also we have discussed about the Dnt, then tolerance limit. Okay friends, so till this lecture we have discussed about this, and now from today onwards we are going to discuss about whatever some examples about how whatever the symbols Dnt going to represent. So if you want to learn whatever I have told you, that previous lectures what we have learned, all these lectures are available on my YouTube channel Creative. You can watch anytime and you can clear your doubts. So friends, today we are going to see about the symbols whatever shown here. So friends, whenever we want to define, sometimes for measurement purpose these symbols are required. So or also it can be useful for manufacturing purpose. When someone want to manufacture this component, that time this Dnt symbols will useful for him. And after this, when someone want to do inspection, that time also this drawing will useful for him for understanding purpose, what kind of tolerance zones, what kind of what we can say, what kind of we have given them to limits. Okay, within that he can achieve the dimension. So both time it is drawing the GDNT important at the time of manufacturing also and at the time of inspection also. So friends, this is one example here for this plate having two holes with distance of 42 mm, and for this bottom we have defined this is A. Okay, datum A we have defined here, and then friends, we want to define the position of these two holes. So here, if you consider with this respective hole, this hole is from this side is 10, and the tolerance zone is given plus minus 0.5. Within plus minus 0.5, this hole is the center of this hole is allowed. Then from this side, the distance across this center of this hole is 8, and plus minus 0.5 is allowed. The distance between two holes is 42 already I told, and then the position of this hole is given here. So position of this hole is the diameter of this circle is allowed in between 9.8 to 9. Okay, so within this it is allowed. Then the center of this hole with respect to A, means this bottom of A, it must be within 0.8. So must be within a 0.8 is required to be there. Okay, and this is we have defined datum P. Then here the position of also defined for this one. The diameter of this small circle is given 6 to or 5.6 to 6. Okay, so 5.6 to 6 mm. Within this, the diameter of this circle is required, and then position also we have defined is a 0.8 with respect to AB. Whatever these circles, the center must be with respect to this B, and with respect to this A must be within 0.8. Okay, so this is the meaning of these symbols. Next, friends, so what is the when the blocks we have shown on a drawing, what is the meaning of this block? So first block, whatever this shown, this is a datum reference. Okay, so this is called a datum reference. Then second here, if you see, this is a tolerance of position tolerance zone. So what kind of tolerance we require to achieve, that we are going to give into this second block. And this third block, tolerance position symbol. So position means what kind of or whatever your requirement of your, that we are going to give here. So this is a position symbol. Okay, suppose this is used when we are going to give reference with respect to only one datum. Okay, when we are going to give reference with respect to one datum, that time we are going to use this one. When we want to define the reference with respect to three entities, okay, or two entities, that time we require to use multi-block. So here the last one must be a tertiary datum reference which you want to take a reference. Then second one is a secondary datum reference, and then first one is a primary datum reference required. Then this is a maximum modified symbol, means material condition. Okay, modified symbol, material condition is shown here, and then this one is a tolerance value, what kind of tolerance value you want. And then this is a position, tolerance type, means this is the position of this symbol we have shown here. So like this, when we want to define our entity with respect to more than one reference, then we are going to use this kind of block. Then friends, one more kind of GDNT symbol is your feature control frame for profile of surfaces. Okay, so we want to define a profile of surfaces. So here in this block we are going to write down the profile surface symbol. The next one is the profile of a surface tolerance zone size. So what kind of tolerance zone you want, and this is a datum reference with respect to which one. Okay, we require to give some kind of references. Okay, with respect to which you want. that we are going to give into this block. So here friends, one more example we have given here. So here the bottom of this plate is we have defined A. For this side we have defined B. For this side we have defined C datum. Okay, so datum means we have defined some references. Then every circle has given, hole has given some dimension. With respect to this is 14, with respect to this is 16, distance between these two holes is 19.1.2, and across this distance is 40. Now friends, when we want to define the position of this hole, is given is the 4, means number of hole is given 4 numbers, into diameter of every hole is 12.5 plus minus 0.3. Okay, so plus minus 0.3 is allowed dimension for these holes. Then the position of this hole, maximal condition is 0.4 with respect to ABC. Okay, the position of this hole means center of this hole must be with respect to ABC. This is A, this is B, and this is C. So with respect to this, the hole must be within this dimension, which is 0.4, and this is we have defined datum D. Now the meaning of this symbol, the diameter of this central hole is 22.2. okay, 22.2 plus minus 0.1. okay, so allowed plus minus 0.1 here. Then the position, if you want to define the position, so here diameter, the position of this 0.2, the center of this must be within a 0.2, or we can say whatever the circle must be within a 0.2 with respect to AD, with respect to A and D. With respect to AD means this A, and with respect to this D, with respect to this circle and with respect to this surface. So we have defined this hole or this circle. Now friend, one more thing, we have given the profile of surface of like this. This is a surface. We have defined this is a surface A, this is surface B, and this surface must be with respect to AB within a 0.03 mm. Friends, this is one more thing we have shown, the profile of this surface within a 0.001 we have defined, and when on this little line, when there is a circle small, it defines that this means over the entire surface. Okay, it allowed over the entire surface. Okay, so it is meaning of over the entire surface. So one more thing we have shown here, the flatness. How we are going to define the flatness of these surfaces. So friends, here you will understand that this is a one square component, and we want to define the flatness of this surface. Okay, so flatness is shown here within 0.001. okay, so actually it is given a tolerance zone. Within this, the surface flatness must be required. The surface of this must be within 0.001. So how it is mean, the interpretation of this is given here. So see friends, every surface means it is a zigzag manner. Okay, when you see in a microscopic level, it will observe that it is a zigzag manner. So it is a zigzag manner means that we want to define, so whatever the top and bottom of this peak and valley dimension. So across this, when you measure, that is the tolerance value whatever given. So must be within a less than 0.001. So whatever the 0.001 mm we can say. So this flatness must be within this value. So here the range is given. Okay, so within this your flatness must be within less than 0.001. So this is the meaning of this flatness symbol. Now friends, one more we have shown here angularity. How we are going to measure the angularity of the component. So also now we required here 60-degree angle. Okay, so allowable limit is the angle we can achieve within 0.03 mm with respect to A. So with respect to A, 0.003 mm tolerance deviation is allowed. Okay, so tolerance deviation of 0.003 mm is, or 0.03, we can say degree also. Okay, 16 is given in terms of degree, so we can say it is allowed in terms of 0.003 degree. Within this limit is allowed for this angle. Now friends, one more thing we have shown here, the flatness of this must be within 0.005 mm, and parallelity with respect to A, we have defined for this bottom surface is defined with A, and this above surface we are going to give a parallelity within 0.01. So this surface above and below must be parallel with respect to each other within 0.01 mm. Now one more symbol we have defined here, the profile. This profile is shown here within 0.03. Okay, so within 0.03 means, see here, this above and lower limit of this within 0.03 mm. Okay, so this must be within 0.03 mm is shown here. Now friends, one more thing we have shown here. So here this surface we have given C datum, this surface we have given B datum, and then the distance of this, and this is we have given A datum. Then the position of this your hole with from one surface it is a 30 mm, and then the position of this hole we have defined here in this Dnt symbols. The position, this symbol is position, the diameter 10 plus minus 0.05 allowed limit, and then maximum material condition must be 0.03 with respect to ABC, with respect to A, with respect to B, and with respect to C. So this is the meaning of this one. Now friends, this is the one again we have shown. So here the symbol of this for this diagram, flatness is given. So here if you see, this is a flat here, and here the flatness is allowed 0.005 and defined A, this datum. Then here the meaning is given of parallelism, the parallelism with respect to A. So whatever this A with respect to this surface we are expecting, this must be parallel with respect to 0.005. Okay, so with respect to this surface, and this must be within 0.005. Then here also given perpendicularity, the perpendicularity of this surface within 0.005 with respect to D, and with respect to this surface. Okay, so this surface we have given perpendicularity with respect to this D surface and with respect to this A. Okay, so this is the perpendicularity we have given. Then here we have shown, so we have defined this is a C for this flat here, actually across this line. So here we have defined the B for this datum. We have defined here the B. Here we have defined the datum is B, and here the meaning of this is we are expecting this circle of center of this circle must be diameter 5, and we have given here 2 dimension. All these are given in terms of inches. So 0.5 to 0.4 inches of diameter of this circle, and then the perpendicularity with 0.001 maximum material condition with respect to A, with respect to this A. Okay, so with respect to this A, so here we have shown with respect to this A surface, this must be within 0.001 perpendicularity, and then the position of this pole is given here, that we required 3 number of poles here. Number of poles required are 3 into diameter 0.250 to 0.247. Okay, 0.250 to 0.247 inches with 0.001 maximum material condition with respect to ABC. With respect to ABC. So with respect to A, so here whatever given here A, then this is B with respect to this B, and this with respect to this. Okay. So like this, the position of this hole is given with respect to A, B, C. So this is the meaning of this drawing. So okay friends, I hope you have understand whatever we have learned today is about what is the Dnt symbols and how these Dnt symbols are writing on a drawing, and then what is the meaning of these symbols. So I hope you understand, and I am very thankful to everyone for listening my lecture carefully. So once again, thank you very much.